Hi everyone. In this video we're going to talk about exponential functions. So far we've looked at polynomial functions, especially lines, quadratics, and then we've also looked at rational functions. So today we're going to talk about exponential functions. Okay, so what are exponential functions? Exponential functions are functions of the form f of x equals a to the x, right, where a is not negative, so a is greater than 0, and a is not equal to 1. Okay, and these functions are called exponential functions. With base a and exponent x. All right. Now the reason we don't want a equal to 1, because if a was equal to 1, then f of x would be 1 to the power x, and we know that 1 to the power x is going to be 1. So we don't want that, right? And so that's why we have a is not equal to 1. So let's look at the graph of exponential functions if a was greater than 1. Okay, so for our sake, what we're going to do is let a be equal to 2, right? So let's go ahead and make a table. So I have the function fx equals 2 to the x. All right, so I'm going to make a small table here. So you have x and you have 2 to the x. So if I take fx equal to, say, negative 2, I get 2 to the negative 2, and that comes out to 1/4. If I take negative 1, that gives me 2 to the negative 1, which comes out to 1/2. If I take 0, 2 to the 0 is going to be 1. If I take 2, I get 2 squared is 4. And then finally, if I take 3, I get 2 cubed. Sorry, if I take 3, 2 cubed is equal to 8. Right? So let's go ahead and plot our points here. So we have so I have, say, 1, 2, 3, 4, and then I have 2, 4, 6, 8, 10, and 12, and then I have negative 1, and then negative 2. So at negative 2 I have 1/4, so 1/4 is going to be about here somewhere. Then I have a half would be about here. And then I have 1 at 0. So this is my point 1 right at the halfway mark. And then at 1, well, I didn't write down 1, but 2 to the 1 is 2. So we're going to have 2 here. 2 squared is 4. And so as you can see, now it's starting to rise pretty rapidly. And then for cube, it's going to be 8, which is up here. And so now if I look at it, my function, join that by a smooth curve, that's what the graph of an exponential function looks like. And this is for the function a is greater than 1. So as a is greater than 1, we see that this is an increasing function. Okay, now let's see what happens when a is between 0 and 1. So essentially, a is a fraction, so you can say 1/4 or 2/4 or 2/3 or 0.5, right? So for us, just for the sake of simplicity, we're going to take a equal to 1/2 or 0.5. And so let's go ahead. So our function now becomes f of x is equal to 1/2 to the x. Okay, so let's make our table here. So again, I have x and I have 1/2 to the x. If I take 2, this gives me 1/2 squared, which is going to be 1/4. If I take 1, this is going to be 1/2 to the 1, which is just a half. At 0, I'm going to get 1/2 to the 0, which is 1. At negative 1, this is going to give me 1/2 to the negative 1, and we'll see in a bit that that actually equals 2. And if I put in negative 2, I get 1/2 to the negative 2, and that equals 4. So I'll go ahead and plot these points. Again, I'm going to get the following. Okay, so I have, let's see, 2, 4, 6, 8, 10, 1, 2, 3, and 4. I have -1, -2, and let's say -3. Okay, so at 2 I get 1/4. So at the point 2 I have 1/4, which is going to be down here. Then at 1 I get 1/2, which would be about here. Again at 0 it's going to be 1. At -1 now I get 2. So you can already start to see that as I go in the negative direction, this function goes up, and it's kind of a reflection of the previous one about the y-axis, or the previous function went this way. So if I join these points now, I'm going to get, okay. Also know that this will never touch the x-axis because there's no way that I can, the denominator keeps becoming bigger and bigger. It'll go closer and closer to the x-axis, so the x-axis will become an asymptote, but this function will never touch or never cross the x-axis. Okay, so let's take a couple examples, right? The first one is we want to evaluate the function fx equals 3 to the quantity x minus 2, and we're going to evaluate f of 4. So what I need to do here, f of 4 is going to be 3 to the 4. Just replace x by 4, so 3 to the 4 minus 2, which is 3 squared, and that is nothing but 3 times 3, which is 9. Okay. Now same way I want to evaluate the second function. So the second function is fx equals -2 times 10 to the x. So I have f of -2, and that's going to be -2 times 10 to the -2. And so this is going to be -2 times 1 over 100, which is -0.02.